Today's topic is OneWire, which is a bus which uses only one signal wire. Of course, in addition to that, there must be the reference ground. But anyways, let's go through some of the facts. Okay, let's see. Yes, there we go. So OneWire actually is based on a single master, and then you can have separate devices there, and actually this is a low bit rate system, only 16 kilobits per second, which means that actually you can put quite a lot of devices there, as long as the capacitance of that wire does not go too high. But practically this is almost unlimited number of slave devices what you can put there. The concept is relatively simple. The OneWire master sets the data line high for a certain period of time, which basically charges the internal capacitors of those slaves. Usually the microprocessor cannot provide that much power, so it's advised to use then some transistors for this recharging part. After charging, the data line can be used for two-way communication, half duplex two-way communication. All the transactions are they are initiated by OneWire master. Yeah, that's just some details. So in practical, you can power this the device from this parasitic power of the data line. On the other hand, if there is a power pin on your device, then why not you use it for this exercise? And yes, in this exercise we are using Dallas Semiconductor DS1820 compliant sensor which has a power supply pin. Okay, some OneWire applications where they are used: eye buttons, real-time clocks, temperature sensors. Okay, there's plenty of examples on the OneWire, but since it's slow, not massive data of course, so it would take forever. So wherever you need few bits sent or few bytes sent in certain, say in a second, then this is a good solution. And especially when you can have the device that it's most of the time unpowered. So to save some power of the sensor, you don't need to apply any power to that power line. It can be left floating or just slow discharging. So that's one of the energy saving tricks for battery operated devices. Okay, PSoC5 and OneWire. There's a catch. PSoC Creator does not have a OneWire component for PSoC5. So you need to either build it yourself or copy a sample project from PSoC community. There's a big community and there are several examples, working examples. I have not tried them yet, but they are told to be working. If they are not working, don't complain me, but whoever posted it there. And then basically you can also copy a OneWire protocol from Maxim Integrated, which is owning the Dallas Semiconductor, and take a look at the application note. Since basically you can use some Cypress delay microseconds software functions, but anyways, let's go and take a look at that device note a little bit later. Right now. Okay, yeah, one-wire communication through software. So there, here basically is the protocol and how it works. And let's expand that picture a little bit. So practically, there can be 4 kind of transactions on the on this bus. So write state 1 means that the master sets this data line to 0 for a certain amount of time A, and that A is on this table. So on standard mode for 6 microseconds the master sets the data to 0 and then sets it to 1 for 64 microseconds. So that section here is let's see, 70 microseconds long. Write 0. Write 1, okay? Or write 0, meaning that first that A and then that much. So basically those are different times here. The bus master sets the data line to 0 for C amount of time, which is 60 microseconds, and then pushes it up, which is 10 more. So that's 70 microseconds in total. Okay. Then read would be same as write 1, except that then basically master samples the data line at, so after writing 1 it basically samples the data line after 9 microseconds from that one, and basically holds the whole section is again 70 microseconds. At some point this device releases the line if it was 0. Okay, and then basically the reset is like the following. G is a standby time before starting this one, so there must be at least this long delay before the previous transaction happened, and G here is, oh well, standard mode is 0, so you can start it immediately. And then reset signal is actually when reset bus signal is when this data line goes to 0 for how many? Okay, 480 microseconds, so it's almost half a millisecond. Then it goes up, then it releases, and practically then basically it samples at I, okay, 70, after 70 microseconds from this one, it samples if there are any devices there on the bus. Okay, so that basically just tells the master that there is a device, but it does not yet tell if there are several devices. On this exercise we have only one wire slave, so it's either answers or not. In case there were several, then each of those actually go and sets that at the same time, except that then there is a software protocol for finding the addresses for each device on the bus. So basically, after finding there is a device on the bus, the master must go and check if there are more than one. Okay. Oh wow, I found some code. Excellent. So see, Code samples. The following code examples rely on two common C functions, out and inp, to write and read bytes of data on I/O locations. So practically it relies on a couple of these functions, send byte, read byte, and actually those are the functions that are device dependent. The rest of that is more or less device independent, like set speeds, which basically sets a OneWire speed either the standard or overdrive. And then there's basic functions like OneWire touch reset, which was the 480 microseconds low, and then sampling. Okay, that was the this one here, the reset. Write bit, OneWire read bit. Okay, what else? Okay, there are even write byte, read byte function. Wow, that looks like it has all you need. That's good. Okay, so practically you could go now and start writing your code on the PSoC5 and tweak it to work. Okay, that's about the OneWire. So let's go through the some of these again. So it's OneWire in sense that there's only one data wire, then there's a ground wire. These devices are very low power, which means that they can be powered from the parasitic parasitic power on the data line. Low speed, the low speed devices only, like temperature sensors, and our example is that DS18S20 or similar. Actually, my device is DS1822 plus, and you might actually have something different. So practically all of these devices are actually the pin and software compatible, as long as it's a DS18 2 something. Okay, and yes, PSoC5 does not have a component for it. So what I actually recommended you to do is to go to that application note from Maxim Integrated and take a look at this code what they have here. Okay, so OneWire communication through software. Okay, so that's the OneWire theory part.